So let's start out with our zeros when we're trying to get a feel for this graph here. We'll start with our zeros and the multiplicities and kind of go from there. So where's our zeros? Where's our x-intercept? So let's let y be 0. And we'll take each of those factors, set equals 0. So x equals 0, we only got one of those. So with multiplicity 1, right, there's only one of them. X equals 0, multiplicity 1. So it hits right there, 0 has a multiplicity 1. So if it's an odd multiplicity, does it cross or touch? Cross, good, odd multiplicity. The next one, x minus 5 equals 0. Solve that for x equals 5. There's only one of those as well. So 5, multiplicity 1, so it must cross. And finally, x equals negative 3. There's only one of those. So with multiplicity 1 as well. So it's got to cross through there at negative 3. Now, what does this thing behave like? What's the power function it behaves like? Well, we didn't multiply it all out, but we could. It wouldn't be too bad to multiply this all out. And we get x to the third plus 3x squared minus 5x squared minus 15x, combined like terms. And all we care about when we're dealing with end behavior, all we care about is that first term. That's called our power function right there, that x cubed, right? So this thing behaves like y equals x cubed for large values of x. So I want to think about that. I'm like, okay, it's a x to the third. It's a third degree. That means it's an odd degree. N is odd. So does it behave like x cubed, which goes down to the left, up to the right? Or does it behave like negative x cubed if I had a leading coefficient that's negative? And you say, what's the leading coefficient? Positive or negative? Positive 1, yeah, so it behaves more like x cubed. So this thing's going to go down to the left and up to the right, just like x cubed does, the classic x cubed. I know it's not just y equals x cubed, it's x cubed minus 2x squared minus 15x, so there's a lot more to it, but you can always plug in a bunch of other points and kind of get a feel for what this thing looks like. So for example, if you want to be a little bit more exact, we already have negative 3, 0. We have 0, 0. And we've got 5, 0, right? We already know those. So I'd plug in a few, like maybe negative 4, negative 5, plug in a few of these, right? Again, just enough to kind of get a feel for it. It doesn't have to be exact. Really, we already kind of have a feel for it because we know it's got to cross through here. It's going to have to come down and cross through there again, and then it's going to have to go back up and cross through there. So we kind of already have a decent feel for this. But ideally, like I say, we plug in a few points. So let's throw in let's throw in negative 4 first. So f of negative 4 is negative 4 times negative 4 minus 5 times negative 4 plus 3. So it looks like this ends up again clear down there at negative 36. Like this is way down here, right? Let's plug in 1 to the right of negative 3. Like, I don't know, let's plug in negative 1. Throw in a few of these. Looks like I get 12. F of negative 1 is 12. Let me go by 2s. 2, 4, 6, 8, 10, 12. And this is just by 1. So negative 1, and it spits out 12. But anyways, you could plug a few more in, but you're just trying to get a feel for this thing right now. You know, it's going to come down. I'd plug in a few here to see how far down it goes before it starts coming back up, but you kind of have a feel for this polynomial, and that's what we're kind of concerned with. So that's this section here. Let's do some more. Let's go to the next one now. Start with our zeros again. So notice we have two of these x minus 3's, right? So I'm going to say I have a 0 at 3 with multiplicity of 2. So does it cross or touch? Touch, yeah. So I know it's just going to touch it either from the top or it's just going to touch it from the bottom. It's going to be one of those two scenarios. The other one is x plus 4. I got two of these x plus 4s, so I have a 0 at negative 4. Again, there's two of those, so x equals negative 4 with multiplicity 2. So it's also going to touch at negative 4. So it's going to touch or touch, right? Let's go ahead and find our y-intercept. Find our y-intercept. Find our y-intercept. Let's go ahead and let x be 0. Oh, what's that? 288. So 0, 288. So let me go by like 30 at a time. 30, 60, 90, 120, 150, 180, 210, 240, 270. So it's like right here kind of thing. 288, 0, 288. Again, I'm going by 30 on this thing. If I was to multiply this whole thing out, what would my first term be? Who does it behave like? I have two of these x minus 3's. I got two of these x plus 4. So what's, and I'm multiplying it all by 2, right? So I have x squared from that x minus 3. I have x squared from the x plus 4. Again, if I multiply the whole thing out, all I care about is that first term, right? It's called a power function. So it behaves like 2x to the 4th for large values. In other words, at the extremities, right? So what is that telling us? Well, I'm thinking to myself, is the degree even or is the degree odd? Even, yeah. X to the 4th, right? The degree is even. N is even. So now I got to determine, okay, so is that like x squared? It goes up to the left, up to the right? Or is it going to have or is the leading coefficient negative, which means it behaves kind of like negative x squared, which goes down to the left, down to the right? What's our leading coefficient here? 2. Yeah, leave it positive. So it's more like this one. Positive, it is like that one, sorry. The positive x squared, right? The leading coefficient is positive. So we know it's got to go up to the left and up to the right, right? And then again, we're just plugging other points in. This will definitely not be exact, but I know I got to come up here. I got to hit that at some point. It's got to come back down. I got to touch right there, and it's going to go back up, right? To be more exact, you plug and chug. You put in some other points, but this will at least give us a feel for what the polynomial looks like. Okay. Let's do a couple more here. Start with our zeros again. Who's our x-intercepts? Notice I have x cubed. So I have x equals 0 with multiplicity of 3. X equals 0 with multiplicity of 3. So it's got to cross through because there's an odd amount of those. It's going to cross through. They will increase through it or decrease through it one way or another. And then I only have one of these x plus 2's. So this is with multiplicity 1. So it'll also cross through at negative 2. It'll cross through one way or another, right? So I have an odd multiplicity. Go ahead, find your y-intercept. Well, 0 times anything is 0. So 0, 0 is our y-intercept. If I'm multiplying this whole thing out, in fact, let's just go ahead and do it on this one. Real easy to multiply this out. That's the term I'm concerned with, right? That negative 2x to the fourth. That's called our power function. So it behaves like negative 2x to the fourth. So our degree is 4, which also means I'll have 4 minus 1. I'll have 3, up to 3 turning points. Up to 3 turning points since it's degree 4. But let's talk about the end behavior then. So the degree is even. N is even. Fourth degree. Does it behave like positive x squared? Up to the right, up to the left? Or negative x squared, which goes down to the left, down to the right? Negative x squared, good. Yep, the leading coefficient is negative. So it's like the negative x squared. So we know it'll go down, and eventually it'll go down on both of these, right? And so then again, the ideal is we plot a few points and we kind of see, maybe we'll throw a few in here. Let's throw in like negative 1. That's between 0 and negative 2. So throw negative 1 in. Let's see where that's at. Two. So negative 1, 2. Right. Ideally, we throw in like something between negative 1 and 2, like maybe put like negative 3 halves in. That'd be a good one as well. But anyways, what you're going to kind of see is it'll go up, it'll kind of come down, and as you plot a few points, but it kind of behaves like we expected it would behave eventually, right? Again, the more points we plot, the more exact it will be with that, right? All right, I'm going to let you guys try this one. I'm going to give you just a second here. I'm going to pause this. So we have a 0, 0 crosses through because there's an odd multiplicity, right? 3, multiplicity of 3 of that. And then the 1.5, negative 1.5 has even multiplicity. So it'll just touch at those points, at those zeros. Y-intercept is 0. The degree ends up being, if you multiply this whole thing out, it'll be x to the 7th. So it'll have at most 6 turning points. So it's going to behave like that, x to the 7th for large values of the absolute value of x. In other words, that's your power function there. So n, the degree is odd. So does it behave kind of like x cubed? Or does it behave like negative x cubed? What's the leading coefficient? Yeah, so it'll be which one? Yep. So go down to the left, up to the right, right? Down to the left, up to the right. You could, again, you'd probably fill in more of this, but it'll come up. It'll have to touch right there. It'll come down. It's going to have to come back up and through there. Then at some point, it's going to have to come down and have another turning point. It'll have to touch right there, and then eventually it's going to just jump right back up. But the steepness of those turning points, you just have to plug some points in and kind of see where they lie, right? That's it for 4.2. At least I'll get you started. Appreciate you guys listening.